Well, welcome to the Structural Modeling Video Conference for November 16th, 2019. Kevin Dye is going to continue his discussion on the history of interpretive structural modeling. So with that, Kevin, I'm turning it over to you.
Okay, I'm just going to share my screen. Hopefully that works. We've been having pretty good success with StreamYard, I think. So it doesn't appear to be sharing yet.
Okay, well, let's see. There's your screen.
Okay. Let's switch to the presentation. So you should have a full screen, a title page.
Yep.
We do.
Yep, people see that?
Yes.
Okay, so a few years ago, I began doing this project that I came to call a conceptual history of interpretive structural modeling. And it's where are the ideas from that led to the practice of structural modeling. And this is in the Warfield and Christakis School of Structural Modeling, and specifically ISM. There are some dozens of structural modeling techniques there, and many of the concepts that are outlined in this work are applicable there. But so far, I'm just focused on ISM. And here's some that we talked about in a month ago, I think it is. What are some of the underlying concepts? Now, a number of these are referenced in the works of Warfield and Christakis explicitly. For example, what is meant by a structure? They do in spots, but structure itself depends on the field or the discipline you're coming from. So if you're in set theory, structure is an ordered pair. That's as simple as it gets. In other fields, the view of structure has a lot more to it, including the idea of networks and different types of structures and so forth. But so just that the notion of structure is something that emerged over the centuries. A big advance that was made by Warfield and Christakis and Harari and others was to come to see the equivalence of graphs, logic, matrices, and algebra. And and by graphs, I mean directed acyclic graphs, the typical systems diagrams that you see. Most of them are graphs. Logic being typically first order logic. We haven't gotten really into second order logic equivalences in the world of graphs, but first order logic, or so-called prepositional logic. Matrices, and in our work, we're dealing primarily with binary matrices. The matrices are useful when you want to represent what's going on within the computer. And algebra, in our case, Boolean algebra, named after George Boole, can be used to represent all the others. and algebra is most useful when you're trying to come up with new algorithms or prove your theory about a structure, whereas the matrix is good for representing inside the computer. The graph was supposed to be something most amenable to human interpretation. And then, so accompanying that, and this is mentioned very loosely or sporadically in the textbooks on interpretive structural modeling, is the idea of representational fluidity. And that's the idea that I mentioned, that it's useful to adopt different forms depending on what your purpose is. Graphs for communicating, matrices for processing, algebra for proving and developing theory, and so forth. So that's one set of kind of related concepts. Another underlying concept, which is almost always presumed, is that we're using interpretive structural modeling, or ISM, and I'll say ISM from here out, is that we're using it as a tool of inquiry or elicitation of knowledge or knowledge acquisition. However, that's not the only way you could use ISM. For example, there was work back in the 80s where a teacher, I think it was in Japan, a teacher would give a student an ISM software on a computer and ask them to go through and develop, for example, their understanding of a biological system. And if the resulting structure was close to what the teacher's structure was, they got a good grade. Now, that's a completely different way. That's not doing inquiry. That's doing testing and comparison. And no one really does that. But one of the reasons I mentioned it here, I brought it back, is that in the age of ontologies, if an ontology is already developed, then kind of this underlying presumption that we use ISM for inquiry, it doesn't make sense. It doesn't make sense to inquire about a structure that we already have an agreement on. So for ontologies, it's good for creating new ontologies. That's the way it's developed. If an ontology already exists, there must be some other reason you use ISM. I don't know what it is. You could be testing someone's knowledge of it. You could be testing the robustness of one system's representation of an ontology or something like that. But in general, there's an underlying concept that we always use ISM for inquiry and knowledge acquisition. Another thing, and this is historical, that was going on back in the 60s and was a preoccupation with both Warfield and Christakis, and I'd say Peirce, who preceded them by 80 years. They wanted to create new languages. So, for example, in the early 60s, I think it was, the PERT language, Project Evaluation and Review Technique. And this looks very much like the type of graphs we generate from ISM. And they wanted to do better. Now, they could have just used ISM to generate PERT diagrams. I did that. It was one of the first applications I used to do, is use ISM as an elicitation technique for a group to agree on the precedence network for a project. but they wanted to have their own language. So they said, okay, we're going to have PERT, and we're going to put a logic gate on each node. You can have an and or an or, and so they came up with another language that never was popular or published about, even amongst themselves, except in the chapter in one of the books on related to structural modeling. That they had another language called the Grail language, and they were very interested in combining text and graphics and how much information can you fit per page if you use text alone versus graphics alone, or if you combine them, do you get more information by having sparser amounts on the page? And anyway, this was a preoccupation with developing ISM. And in one sense, every time you conduct an ISM session, you are inventing a language that is specific to the context and the situation-specific language, where all the nodes have been defined by the participants, and all the relationships have been agreed to by the participants. Another underlying presumption, which is historical, which really even goes into the 1950s, is they viewed, excuse me, they viewed the participants in an ISM session as information processing units. They were computers, and their model of how people worked, and in terms of coming up with the methodology, was based on how much information are they processing right now, how much are they communicating between people, how much information are they going to be surrounded by on the walls, how much information and is in any particular question, and that was the model. And that actually is something that should be revisited, because now the problem is not so much how to process information overload. That was the concern going back even to the 50s. We've learned a lot about how to do it, and the techniques of ISM are good at information processing in a group. But the problems we have now are more concerned with polarization amongst the participant groups, and we don't have good techniques for doing that. And in fact, a number of the presumptions behind ISM don't really accommodate the social dynamics of polarization and conflict that well. Another, a related concept to the people as information processing units is the idea that we have to simplify things for the participants. Now, the most famous paper about this from Warfield was called The Magic Number 3 ± 0. And it was a response to a paper by Miller called The Magic Number 7 ± 2. And that was a study of how many random digits could someone remember. And so Warfield's premise is that if you're asking about structural things, which in its simplest definition is an ordered pair, two things and their relationship, how many of those can you ask at once? So he said, well, you could ask 3 about the relationship of 3 things, because there's 3 ideas, and there's be 3 relationships between those 3 ideas. The triangle is the structure, basically, and then the relationship of all of them together, and that's 7. And Miller said that you can't remember more than 7 things. So based on this rationale, they came up with asking questions about to generate a structure, the inquiry approach to elicit all the parts of a structure was to never have more than two ideas and the relationship between them. Because even though Warfield said we could do three ideas and the three relationships and the relationship of three together, he says maybe you could do that as an individual, but in the context of a group, people can't do three at once. It's too hard. It's too complicated for them to talk about. So we can only do two. So that was the rationale that drove the whole inquiry approach for the next 40 years. And this became in the mind of Christakis the way that he explained how he was saving the participants. It was what I call the facilitator as hero model. And he would say it was his responsibility to protect the participants from information overload by just asking them, the relationship between a pair of ideas. And so that's an interesting, merger of his Greek heritage. He grew up with the mythologies of the heroes, the great heroes of the culture. And he viewed himself as a hero of the underdog. He himself had been an activist against the British in Greece and had been jailed for that. And he viewed himself this way. The funny thing is, it was completely opposite of what they did in the room, which was to follow the influence of the concept of social planetarium of Harold Laswell. Laswell was a political scientist from Yale, and he had a number of key ideas. One was a decision seminar. Another was a pre-legislature. Those ideas were, we didn't make progress in the legislature because people they didn't work together enough. They worked as individuals, and they needed to work together simultaneously. And they needed a planetarium of all the information. He called it the social planetarium, surrounding rooms with all the information about the situation. And you're familiar with this idea, like Churchill's war room over in England from World War II, and Rand Corporation was big on that for a while, and Battelle Memorials. A lot of the think tanks worked on the design of rooms that bombarded you with all the information. And so it was very funny that they juxtaposed this idea, I'm the facilitator, and our method will protect the people from overload because we focus on a question one at a time with between two ideas. And then we open the gates and flood them with hundreds of ideas on the wall. I was in a project where we had over 300 ideas on the wall. And then there was like 20 clusters of the same ideas reformatted in another way. And then another wall that was covered with the structure 20 foot wide, pasted up with tape as the arrows between the ideas. It was completely overwhelming. And what happens is people lose their fixation on what they thought was the problem. I called it, my personal first experience going through this was, I called it grieving the death of my worldview. I lost it by being overburdened. My brain had to reform what was going on. So anyway, there's a paradox in how they present themselves here, and that's both conceptual influences in their method. They employ both avoiding information overload, but also what they call the unshakable cognitive burden. They force you to confront all the ideas and listen to all the ideas. And one of the problems we have today in deploying ISM on the internet is almost no one forces, in the way it gets implemented, no one forces every participant to listen to the ideas all the ideas of all the other participants the way we do in face-to-face sessions. The internet, every internet deployment I've seen over the past 20 years just give you the option of reading what the other participants have done. And that right now, I've been working with the people at the Future World Center over in Cyprus are doing a version, a mobile phone version of ISM. And we're working on techniques that nudge people to go over or see what other people's contributions have been. So here's a few that we haven't talked about yet. One, and this is the first one that I would connect to Helena's presentation on semantics and semiotics and patterns. And that's the lumped parameter assumption. And this isn't really talked about by Warfield and Christakis. It is by other people in the early systems science movement that were starting to do systems diagrams. And the idea, on the one hand, is straightforward, that if you have a digraph, so nodes and arrows between the nodes, so it looks like a network type of thing. The presumption, the presumption is that the nodes don't bleed. By that I mean all the meaning of the node is contained within the node. It doesn't bleed out or invade the arrows. And this is related to the longer history of the notion of transitivity. When they were coming up with the idea of transitivity, which took over 1,000 years to really get the one that we currently accept, the real breakthrough was to recognize that the meaning of transitivity of that rule, right? A influences B, B influences C. Therefore, by transitivity, we can infer A influences C. The secret behind that rule working out is that the meaning of the relationships were in the relation. They didn't bleed into the nodes. Here, the lump parameter assumption is the complement to that. That what is the meaning inside the node doesn't bleed out into the arrows. So there's a implied modularity. Now the connection to the last presentation our group had from Helene is language and semantics and semiotics is a lot more complicated than that. And if you look at, the language inside a node from the transcript of someone's presentation of their idea, their clarification of the idea, dialogue about what it means, people's counter proposals of what it might mean, and the retort of the individual, and people's questions about, is it similar to other ideas? Does it have relationships, other kinds of relationships to other ideas? All that goes on in every ISM, almost every ISM session, that level of complexity. And so, for example, when someone says, okay, we're talking about idea number 11, and John is the author of idea number 11. I say, John, is your idea similar to idea 23? And he said, I haven't thought about it, but I suppose it is. Okay. So when we go to do this ISM structure, we're usually doing influence modeling. And when we ask about idea 11 and does it influence 15, are we asking about some modular relationship between those two ideas? Or is something from idea 14 also imputed into 11? Right? Does the richness of these ideas bleed into each other? If we allowed people to talk more, would they eventually come to agree 14 and 11 are really two shades of the same idea, and we're going to have a new idea 125, and it absorbs those two ideas? And that happens all the time in ISM. We absorb two ideas into a new single idea, and it either has a new author that adopts it, or it's a multi-author idea. But there's only so much time that you can spend doing things like that, and there's always a lot of ideas left around the table that we don't get that far with. But I think that implies that there's, this bleeding out of the ideas across the arrows, and violates the lump parameter assumption, and therefore violates the modularity implied in a graph and a matrix. And so one of the interesting things about technology that's evolved in the past several decades is text analysis. And I showed pictures of this some time ago about the United Nations Reinventing Democracy in the Digital Era project. And we used several different text mapping tools, and it generated network diagrams of the text behind all the nodes. And so the idea was that we were lifting this lumped parameter assumption and say, okay, this is how the network of ideas or meanings behind the word maps out into the words associated with other ideas, and then we overlap what is the relationship of the influence diagram that we've done with ISM on top of that. And that gets to the next underlying assumption, and called separation of concerns. And that phrase goes back to a guy named, I'm not sure how it's pronounced, it's Dijkstra, Dijkstra, something like that, back in the 70s. An article he wrote on what science was supposed to be about, but it got picked up by people in the software engineering theory community. And with respect to ISM, separation of concerns means we typically model one relationship at a time. So if you look at an ISM diagram, all the arrows are of the same type in that diagram. They're all like influence, or they're all precedence, or they're all priority. Hardly anyone's used ISM to create a mixed mode graph. One of the reasons for that is we didn't really have good math for doing matrices that did multiple relationships in the same matrix or combination of matrices. The way I've seen several implementations at this point is they use multiply different matrices, and they map across them, and haven't seen it used yet, but it is something interesting to think about, because in the theory of separation of concerns is you focus on one thing at a time of interest. But similar to the unshakable cognitive burden thing, people can take in a lot. And I was even about 25 years ago reading about studies that said people can pretty much follow 4 different relationships between 2 things at a time. So, if you want to have a kind of a richer representation along the lines of Helene's presentation, the semantics and semiotics, those are much richer than we generate in ISM. Then we might think about an ISM that, we do maybe 4 different independent mappings and then superimpose them and start to find out how helpful that is. But it is an underlying assumption or concept that has never really been challenged within the ISM community, as far as I know. I mean, Joe might know different because he's familiar with some other theorists that I'm not. And we mentioned the originality. Another is the directionality. Hassan Ozbakan and Harold Laswell, other people in the early days influencing those people were experts on planning. And so the directionality that they were typically interested in was going forward. And in the 80s, for some reason, John Warfield became preoccupied with what he called problematique, and that was more diagnostic. And so he was interested in finding the root cause of things. So that's going backwards into the origins. And we don't often think of which directionality are we intending to go these days. If we're not doing a problematique or an action plan, what is it we're building a model of? And the funny thing is, the origins of the impetus for developing ISM in the first place was to be a front end to modeling systems dynamics, which were largely circular types of things that didn't have a directionality so far. And one of the reasons that happened is the software that they developed originally was directional, and to do what they called geodesics, or to have cycles or do things like causal loop diagrams or systems dynamics diagrams, it was a fairly involved algorithm, or just a procedure, let's say. I believe it's in the book Societal Systems, which is Warfield's 1976 book. But they dropped using it, and as a result, they never continued to cultivate it as a front end for systems dynamics, and they sent the whole field of structural modeling on a separate track from the systems dynamics community, and that's horrible. They split because they were teamed up with Jay Forrester to develop a front end for doing systems dynamics models Forrester figured out how to get the whole grant himself and develop, what became known as the world model. I think they're on World Model 4 with John Sturman over at MIT. And Donella Meadows made famous with the book Limits to Growth. So they became their own little thing, and they had their own approach for doing the front end, and they didn't try to do group work. They worked as individual analysts, basically. And whereas what Warfield and Christakis and Özbekan were trying to bring was a group interface to that. And that all got lost for like 20 years. And then some people from the systems dynamics community started reaching out. I worked with one up in Worcester and to use ISM as a front end. But it was this kind of lost process called geodesic cycles in the Warfield and Christakis loop. So that's something we've kind of fixated into doing, either root cause analysis or planning when, we could be doing kind of so much more. I think another presumption is that of mixed media. In the 70s, when the early days they were developing it, they wanted a combination of graphics and text, and by that they meant diagrams and text. They never really used pictures. And I don't think I saw any pictures where the nodes were pictures and that type of thing. So they were very interested in developing hybrid languages. This was part of their drive to enhance the amount of information you could fit on a page. And but they never really developed theories about that. They just developed a bunch of techniques, and most of them washed out by the mid 70s. But now there is, even 15 years ago, there started to be much more actual research on hybrid languages, and maybe we should revisit that. And another concept I'll mention is the notion of compound dependency. And this is a phrase from work by Tom Malone at MIT on the process handbook about 25 years ago, something like that. And it was part of a project called Reinventing Organizations of the 21st Century. And so he was doing models, basically process models for doing business process reengineering. Was really big in the few years before Malone started doing this work, and he wanted to give a tool for that and become the one-up guy on business process reengineering. And similar to what Warfield did 20-something years ago, he wanted to have his own language, which he called the process handbook. Anyway, one of the very interesting ideas is when you're doing the process models, he would say that the arrows between things, let's say it's precedence between two activities, can be richer. They can have some type of influence relationship, much like Warfield and Christakis do. But in his software, you could click on the arrow and it would give you 4 sub-arrows. There was precedence behind the relationship. There may be priority behind it. There may be a value, which goes the opposite direction. An earlier thing has to come before a later thing, but it might not be as valuable as the later thing. So the arrows don't necessarily all go in the same direction, even though they're from a compound dependency. And I think that's also related to when we want to talk about pattern languages or semiotics, that the arrows, if we get stuck with just dealing with one kind of arrow at a time, it makes it easier for people to talk about it initially, but it doesn't represent this situation that richly, and maybe not even in a recognizable fashion. Let me just check in here. Yeah, just pause and see if anyone has any questions.
Well, Kevin, this has been very, very interesting. I think that you've covered a number of the influences that drove the development of the art structure. And so you've talked about, first of all, that, you know, they only had one type of relationship and one type of matrix, but there's all these other impacts and influences between matrices if you may do more than one. And that's what the art structure is for. It's built to basically handle that, and not only within the logical frameworks. One matrix is a logical form, like your presidents or your whatever your relationships are. You can have a couple matrices of that, but then the next matrix could be a process that's saying, oh, we're going to take this value system. You've been talking about some things are more valuable than others. And we can process that matrix in a value system in some way. And the ways that we've demonstrated in the past were evolutionary algorithms and evolutionary computation to do a large-scale search and to find the most valuable solution associated with the existing structures. Then the other part you talked about, which I think was just great, hardly anyone talks about it, is Yoshi and the people from Japan. And what they do is exactly in the structures, they will take, like with the human body, which we know the structure, and they'll do the structure of all the connections and everything. And then that will be their information base that they start from. But then what happens is, oh, a person is injured. They injure their right arm, or they injure their foot, or they have some kind of deficiency in the structure. And then you have a therapeutic pathway to bring them back into health. And so they use the ISM structure to do exactly that, to say, oh, I have this one structure, I do my ISM analysis, but then I determine the highest value pathway forward. And in all these cases, like you talked about the different theoreticians, Donald Stewart, which started DSM, and Warfield both wrote in the early parts of the statistical. So forgetting the name of the journal right now, but it's for applied statistics and applied mathematics. They referenced each other in the 60s on the way they did their models. But there's two basic forms of a matrix model, one for solving equations where you have each row and then equals something where you've normalized all the variables. And then there's another one where you just have a Boolean matrix, which really doesn't equal anything. It's just encoding the pattern. And I read those articles and looked at them. I don't know if you looked at them before, familiar with them, but the forms look the same, but they're talking about two completely different things. And so what you're saying, I think, is really, really important. The art construct itself is a general way to actually approach these in integration. And that's where I will stop for now. But I really appreciate this. This is great.
Yeah, I'd like to concur. It is really good. Absolutely fascinating. As usual, when we have these conversations, what comes up is we could sort of go off in about 12 different directions with this. And I would like to pick up, Kevin, on what you were talking about geodesic decision cycles. That was one thing that I'm very interested in, because I just attended a day-long workshop with Joe Truss, who worked with Stafford Beer on Syntegration, but looked at geodesic structures as the basis for, the cosmos, but then applied it to the structuring of conversations. And, your point too about how Warfield focused on group communication, and Jay Forrester and others went off to look at sort of individual, is a profound distinction that was made. And I think, anyway, I would like to know more about, your perspective on geodesic cycles, and I would also like to follow up with Joe on what he talked about there in Japan. I'm not familiar with that work. I'd really like to know more about that. And could you make your slides available to Kevin, please?
Sure. On the slides, this is the slides I had today. I can send out. The slides from this presentation are too big to send through email. We've tried in the past, and I have to kind of parse it up and put it on a Google Drive or something to make accessible to people. So
you could also make them in PDF and compress the PDF. Sometimes it's
might be possible.
Yeah, but so they're not PowerPoint anymore, but they're viewable as an image.
Right. Yeah. On the geodesics, the word geodesics, as Warfield was using it, was the mathematical sense of the great circle on a sphere, the largest circle on a sphere. Why he wanted to use that word, I don't know, but what he meant was cycles. Maybe they used that word in some matrix math book he was referencing 40 years ago. I don't know.
Okay.
But what happens in any of the ISM software that I've seen anyway, when you get a big enough cycle of ideas, the entire matrix collapses to a single point.
Really?
Yes. And it's really dangerous, because when you're doing a project, like I was in a project that had 80 people flown in from all over the country.
Right.
Right. And we did, hours of work with ISM, and next to the person that was running the computer to crunch the matrix was me tracking the answers to all of the pairwise questions and doing a running diagram of what is the emerging structure. Because if the computer crashed, it was unrecoverable. You could not go back a step and say, what was the structure just before the crash? And so another way to deal with it was every time there was a few after someone answered the question, we'd save a new version of the file and put it in a backup area,
right,
and onto a new computer and print the current state of the structure. So to actually run one of these things, we had someone running the ISM algorithm to display it to people, and then enter their yes/no answers. But there's also someone manually tracking the log file, and another computer running a step behind. So if that one crashed, we knew not to go the same step. And the other, so that was one aspect. Is all ISM software suffers from this. They don't. It's built under the presumption that they're not modeling major cycles, or so-called geodesic.
That's a limitation, though, isn't it? Isn't that a massive limitation?
Well, it depends on what you're trying to model. You know,
Well, if you're trying to model 80 people's, definition of a problem.
Well, I think that maybe a simple example, maybe to help make sure that we're all talking about the same thing here, is just equals, right? So that's one of the examples in the handbook, is what things are equal or in the same class. This thing is in the same class as that. And that is a symmetric relationship. So therefore, it is actually cyclic. A is in the same class as B. B is in the same class as C. So you have, in that relationship, you have a cycle. And if you have 30 things, right? And out of that, the people decide there's 4 categories of those 30 things, then those 30 things will collapse into 4 categories.
I see what you mean.
And so that there's filtering going on. It's not that it's always bad, but in the implementation, these are 2 completely different versions of the software code. And so if you can't, in the older ISM software, you could not mix those. If you mixed them, you were in trouble because you were getting the wrong approach. And so they had a switch in there, what you're going to do. So I think it's
also,
anyway, we got another 9 minutes.
it also depends on how you ask questions. So if you want to understand the relationships of things, I'll give you an example. We did a project for a church, 2 churches that were merging, and they hadn't been able to do it in over a year. And there's a lot of animosity because one church had all the money, the other church had the location, and the people with the money wanted more control. And anyway, we went to do an ISM structure on what should they do. And at the last minute, without telling me, the facilitator decided to change the triggering question to be, how should we be? He wanted to inquire about states of being, and he wanted people to answer in the form of gerunds because he liked the ing form of words. So he wanted to hear loving, hoping, eating. He wanted to hear words like that start out the beginning of each idea. And I said, so that's what he had put into the computer. I said, if you do that, you will end up with no structure. You'll have one cycle where everything is related to everything else, because states of being in general, they're not transitive between each other. Now, if you say loving, does loving precede hoping? People can come up with ideas, of course. And does hoping precede loving? Yes. And so I got them to get at least a few ideas in that were not based on these gerunds. And sure enough, they spent all afternoon doing the structure, ended up with 1 dot on the screen and 1 idea, which was come up with a new name for the church. Now, that saved the whole project because it wasn't a gerund. It was one of the few gerunds that weren't in there. And it was so clear to everyone, if we just come up with a new name for the church, it's going to help us. To my mind, it was kind of a waste of the afternoon in terms of, because I'm trying to generate a diagram. In terms of the project of the church, it was incredibly successful because it was so clear what to do. There was one thing to do.
Restate the identity. Yeah.
Restate the identity. Yeah. And anyway, but was there another?
Well, just what I would just like to hear more from what Joe was talking about in terms of Japan there, and the body relation, and what I didn't quite catch the name of what you said there, Joe, and how that related to what Kevin was talking about.
Let's see. I think hopefully I'm pronouncing the fellow's name correctly. He signs into the Systems Science Working Group from time to time, Yoshi, and but they have a advanced systems department and group. I don't know if it's a combination of the Japanese government and their university or whatever, where they work on all types of structures, and they published a lot of work back in the 70s. I think they might have even done the fuzzy ISM. Let's see. And I also think that they were the ones that, and let's see, Warfield said the guy on the North Island in Japan. So I think that was Yoshi. He didn't really say his name. Did the come up with a type of fuzzy approach to the transitivity issues. And so what Kevin was saying was most everyone uses ISM as a type of inquiry, but you start from zero, right? I don't have anything. I don't have any real complex structures already encoded, right? But if you have like a body of medical knowledge, you have a massive amount of structural information already encoded, right? And so can you wrap that body of knowledge with the ISM tags? And so you tag and form it that way. And then when something happens to that structure, right? When that structure starts to change, then you can get information about what to do, right? And so it's a completely different approach than the inquiry and problem solving from just starting from zero. It's an unknown, right?
Right.
Could I say a word before, we
Sure.
only have 3 minutes left? So I was super interested, yes, in the idea of having multiple arrows and superpositions and trying to get to the bottom of things, because I think there are two things. They're about what Joe was getting at, that there's existing bodies of knowledge, and how can ongoing conversations inform the evolution of the body of knowledge, or the understanding and parsing, let's say, of the body of language, of knowledge, sorry, which it's an interesting lapsus, though, expressed in different types of languages. But the other thing is about space and time, because there are differences of representations, both in space, so different disciplines, different whatever, and in how things evolve in time. So I'm not going to elaborate more on that, but this is the type of thing I'd like maybe to dig a little bit more and see what potentialities there are. So I'll reach out to you, Kevin, about that. And just to say, Joe, that I've been reading the book by, what's his name, Bergman. And it's really, thanks for the reference, because it really touches everything that I've been talking about. So how can relations be qualified in multiple ways and in evolving ways? I think this is where it tries to get to. And I'll stop there, because maybe Janet wants to say a word.
Thanks. Couple of things. One is, Kevin, I think you should write a book on this. These two presentations are fantastic, and your insights are really good. It doesn't have to be long. Picture it as an orienting guide, because I think the conceptual history approach is really rich.
I agree.
It could be a companion to your playbook. And I don't know the state of that. But if you want help writing the conceptual history book, I'm volunteering to edit for you, because I think, and the other thing I was thinking is that Peter started a process of taking these tapes and having them transcribed. So I think you could take your first, I don't know if it was 40 minutes or so of your presentation and have it transcribed, and that gives you a rough draft of today. I don't know. I think we interjected more in the last one, so I don't know if that's as worth doing, but possibly it is. So Peter knows a service that can do that. So that's on the book side. On the idea of the being surrounded, I love the death of your worldview, mourning the death of your worldview idea. I think that's really rich as well. And the fact that people are not surrounded when you're sharing virtually like this, even, you're not compelled to confront the, simultaneously being surrounded. That's an interesting issue. Reminds me of the notion from, I guess, about 10 years ago of co-inhabited information spaces, and maybe augmented reality is a way that could be addressed, but that's further down the line.
All right. Well, we're now at the hour, so take a minute or two if anybody has some final comments you'd like to make, and wrap it up. We'll December 7th, Mary and I will continue with the ontology discussion.
Thank you, everyone.
Thank
Thank you, Joe.
All right. Take
Thank you,
care. Have
Kevin.
fun. Good job, Kevin.
Thanks, Kevin.